unlike X, SpaceX is not going to go away that easily. Okay. If anything, SpaceX will keep growing. That's my belief, that when you have deep tech, so we are just not curating ideas, we are curating entrepreneurs. We are curating faculty who become entrepreneurs. Reliance actually say, I'm going to actually support this work, and whatever we help you productize it, and we want you to try it out on our, and we will also buy 200 of these sensors if it works.
Hi, my name is Amrit. We've heard that IIT Madras is the best place to build. So we've come down to the Sudhan Shankar Innovation Hub. We want to meet some people. These are builders. We want to talk to them about their work and also ask them what makes IIT Madras the best place to build. Hi, welcome to the Best Place to Build podcast. We are sitting today with Professor Krishnan Balasubramanian, who is a professor in mechanical engineering at IIT Madras. He's a very well accomplished and very well loved professor, award-winning professor. Recently, in 2017, won the Abdul Kalam National Innovation Fellowship. Welcome to the podcast, Professor.
Thank you, Amritash.
Professor,
Very happy to be here.
And also, I might just start off by saying that I was a student of yours in your class in 2003-4. First year, second year. So I have memories from the class also. So really happy that I'm meeting you again after so many years. Professor, you've had a long career in IIT Madras, and you're obviously associated with a lot of things. But let's start from the beginning. Can you talk to us about your research area and the work that you do as a faculty member?
Thank you, Amritash. Feels long, very short, but it's probably 5. It's getting to be close to 25 years since I returned back from US and joined IIT Madras. My area of expertise is in an area called as non-destructive testing, which to many of you may be foreign language, but essentially you all remember that whenever you have anything to do with your health, you go to a doctor and then the doctor says, go get an ultrasound done, go get an X-ray done. What you do is you look inside your anatomy and you're able to find out if everything is okay or if something is not okay. Now imagine the number of engineered structures and components that you use every day, whether it's a car, you're taking a flight, you are in a train, you're using the rail, you're using the bridge, crossing a bridge, you have pipelines, transporting gas to your home. You have sewage lines. Each of them are all good when you're building it. And then over a period of time, things start to go wrong. And when things go wrong, either things become unavailable to you. Imagine suddenly that you have a flight that's cancelled because of some maintenance issue. Now, if I can prevent that by letting you know that this plane has a problem, and then when it's not being used, you fix it, then it becomes available for you every time. Of course, you can also look at it from a different perspective, that we are looking at safety. So if you look at the number of catastrophic incidences that happen, if I can prevent many of them, then that is a mission that we are embarked on. So we look inside materials, we look inside components, engineered component, we look inside structures, just the way diagnostic center just down the road from you looks inside your anatomy and says whether you have a valve that is not working or whether it's a heart that is blocked. Exactly the same thing we do, but big difference is that your anatomy has not changed in zillion years. On the contrary, engineered materials change almost every year. Components gets redesigned every couple of years. So our problem and challenges are evolving on a daily basis, and we have to keep solving newer problems because we have new materials, new problems associated with new materials. I can give you one good example. I remember many years ago, the railways came to me and told me that the wheels are cracking up, and there have been accidents because of that. And the reason why that happened was because they changed the brake pad from metal brake pad to a composite brake pad. Why did they do that? They did that because composite brake pads actually stop your train much closer. So within about 500 meters, you could stop the train. Before, the train would take 2 kilometers to stop. So that looked like a brilliant advantage. But what they didn't realize, or probably what the challenge here is, that the kinetic energy that you have has to be dissipated in 500 meters, what was dissipated in 2 kilometers. So now you have heat that's heating up your wheels a lot faster, and then your metallurgy is not able to take it. So now they wanted to know whether I can predict which wheel is going to fail so that they can remove it out before anything bad happens. So we can do this by many of the NDT methods that are available today. Thank you.
I remember in class you said, you'd mentioned that the idea of non-destructive testing implies that there's destructive testing, right? So then,
Right.
like, what would that look like?
So eventually, destructive testings are things that you would not want to do in real life. Destructive testings are ones that you do in your laboratory and to confirm certain hypotheses. Doing the same in real life, it is like, I would give you an example. Again, going back to the medical field. Suppose I want to look inside your heart and I want to find if one of your arteries is blocked. Imagine that I have to cut you up and then go to the artery and find if the artery is blocked. What are the chances that I'm doing the right thing? You may wind up in a worse situation afterwards.
Right.
So the idea is not to do that. The idea is to make sure that you find what's inside you and do it in a way by which your performance or your activities are not hampered at all. That is non-destructive testing.
Right. So anything that is like a civil engineering structure, like a bridge or a building, but also like ships and pipelines and sewage pipelines you mentioned.
Pretty much anything you talk about, right from this mug that is manufactured to the plane that you're going to fly out, the airport that you're going to land on, the tarmac that you're going to walk, all of them need to be maintained. Right. So we actually come at primarily two areas. One is when I'm manufacturing, is it good or bad? So defects or anomalies happen when you manufacture. So for instance, one of the biggest challenges is welding. Welding is used very commonly. It's probably the most used joining method in the world. And when you weld, there's still, we know we've been working on welding for last maybe 50, 60 years. Interestingly, I had hosted the American Welding Society's vice president, Richard, only yesterday. And we had a very similar conversation. And the question that I asked him was 50, 60 years of research, advancement of welding. The industry is asking, can I weld and be assured that every weld I do is good enough? We are not able to do that even today. Because and the answer he gave me was one word. He said entropy. Krishnan, we do not have the control over the entropy. And the entropy in a welding process
is very high.
Is high. So we haven't gotten there yet. Then my question to him was, will we get there? And his answer is probably never. Because every time we think we have found the solution, the challenge changes. New welding processes happen.
Correct.
New materials are welded.
Yeah.
I'm just giving welding as an example, but you can extrapolate that to any manufacturing process. So at manufacturing, we need to ensure quality. We need to make sure that the quality is acceptable and do it without destroying it. All right. Okay. Now, once you put anything in the service, again, things are not going to remain the same. Just the way your human body deteriorates, your joints starts to give you trouble once you cross a certain age limit.
Yeah.
Same thing happens with materials. So 3 years, 5 years, 10 years down the road, engineered structure starts to show weaknesses. You have a big problem with a thing called corrosion.
Yeah.
If you want to know what corrosion is, just go outside your building and look at some of the metallic pipes. You see this brown looking dinge on the walls or nearby. That's corrosion.
Yeah.
Okay. Corrosion is today a $5 trillion problem for the worldwide.
It's also a problem that we like when I move around in a city and there's like these metro structures and there's some metal parts are exposed, right? And you can see that they've started corroding. And in my mind, I'm always wondering whether the corrosion is only outside or inside also, right?
Exactly. Exactly. You hit the nail on the head. What NDT does is actually look inside. So, for instance, you take a bridge or any concrete structure, there is as much steel as there is cement, or probably more.
Yeah.
If you take a tire, your automotive tire, there's more metal inside the tire than rubber. And metals corrode. They corrode aggressively, to be honest with you. If they get exposed to oxygen, they get exposed to anything that's like water. And if there are any minerals that, help the corrosion happens very aggressively.
So this is the use case for NDT. What are the technologies that are used in actually doing NDT?
Very similar to medicine. We use X-rays, we use ultrasound, we use infrared imaging. I mean, every time you walk through a airport, you remember that there's a camera that's looking at you, and that's the infrared. That's looking at the emission, the heat that your body is emitting. So we can use that. Nowadays, we can use many others. Radar is used very extensively today for certain materials. You can also use a new technique called terahertz imaging. Now, if anybody wants to know what's terahertz, if you go to the airport, and now you have these body scanners, you go and you stand and then it does a scan. That's a terahertz scanner. In fact, the guy will say, you're holding your ticket in your pocket, remove that. They can pick out a piece of paper behind your cloth, leave alone a metallic object like a weapon. So we are able to look behind materials and look inside materials. We are able to find anomalies or defects that are as small as several microns to or as large as I said, maybe several inches big. Now, depending on the application, for instance, if you say an application of ISRO, for instance, for ISRO, it's almost they have to look at that nothing that is going up has even a 0.0001% chance of failure. So their requirement is almost quote unquote have to be defect free. On the contrary, if I'm building a railway carriage, I can probably live with much lesser stringent requirements. So depending upon the application, depending on the material, for instance, ceramics cannot tolerate very large defects. Certain metals can tolerate much larger defects. Concrete, for instance, can tolerate very large defects. If anything, the concrete floor on which we are standing or sitting is actually got a lot of cracks. But then it can withstand these large cracks and stay okay for 50 years, 100 years. So depending on the material, depending on the application, what we are looking for is different.
Did you imagine when you entered the field of NDE, I guess the field has itself expanded a lot. And when you joined IIT Madras in 2000, at the time, were there other professors who were working in NDE?
Not really. There used to be some work going on before I joined, But then that professor, Professor Prabhakar from metallurgy, retired in 1996, if I'm not mistaken. I joined in 2000. So things were not much happening, but there was tremendous interest. In fact, IIT Madras, I was in the US. I was working in the field of NDT in a university. IIT Madras solicited me. Okay. They said, we realize that there's a tremendous potential to create a research facility and a research center of excellence in the field of non-destructive testing. There's a lot of support from the industry. We have nuclear power plants coming up just 50 kilometers away. We have an airline industry that's growing very significantly. We have a manufacturing industry that's growing very well. So we believe that we need to put a center for NDE in IIT Madras. Would you be interested? So that's kind of was prompted me to sort of look into IIT Madras, and then director Professor Natarajan said, come on board. And I also had a very good friend, one of the, probably my mentor, Dr. Baldev Raj, who was the director of the Indira Gandhi Center for Atomic Research in Kalpakkam, which is 50 kilometers away. He basically said what Lord Krishna said, put faith in me and come. So I put my faith in both Professor Natarajan and Dr. Baldev Raj. And I packed my bags, sold my house in US, and I just landed here. And I said, here I am. What do I do? I landed on 1st of February 2000. Okay. And then they gave me a small office and said, do something. So it took me a while. But I must say I'm incredibly encouraged by the support I've had from IIT Madras administration, support from all the industries, particularly the atomic energy industry, the space industry, ISRO and others, the defense industry. They were the first supporters. Very soon, private industry also started pitching in, right? So interestingly, I landed here with nothing except by a suitcase on 1st of February 2000. 1st of April 2001, we inaugurated a 1,500 square feet advanced research center for ND.
This is the Center for CND.
As you see today, the main block was done in 2001, and we got it done within about 7-8 months. Right? And we had started getting projects quite actively, and I realized why I was asked to come back.
And in the last 20 years, of course, CND has grown hugely, lots of industry and consultancy work, lots of startups. I think before the interview started, you informed me that the startups that have come from CND itself have employed over 1,200 high-skilled professionals.
Yeah.
Of which 100 are abroad. There are 7-8 countries you operate in. So it's a very high-impact center, right?
Thank you. Yeah.
Yeah. I mean, amazing. Really amazing. And to imagine that it started from just a 1,500 square feet building. 1,500 square feet room, I guess.
From a suitcase.
From a suitcase. Right. But Professor, you grew up in Chennai, right?
To some extent, yes.
Okay. It must have also been like a homecoming for you.
Absolutely.
And was there a trend at the time where professionals were coming back from the US?
I would say I was in the probably the first wave. I would say, I don't know whether it is the way that things were changing in India on one side, or whether it was a dot-com bust, as they used to call it in those days, the late 90s. I don't know what it was, but we were I was probably one of the first wave of people that started coming back to India. And it was a very different India compared to what it is today. Right. But you could see the writing on the wall that India was on the upswing. So it was better for us to get on the growth curve early on. And it was harder to get on the growth curve, but definitely the payoffs are a lot bigger. So that was a sort of the motive. But as I said, for me, it was very simple. IIT said they wanted me to come back. And I've always told the people in my friends here that if the right opportunity presents, I will give it a shot. Coming back from US after spending about 16 years in the US, it's not an easy task. You're scared. You're scared whether you will be able to adjust back. You have to learn to do things very differently. I got lucky, let me put it this way. I think it was meant to be, as I would think. So it really, a lot of good things and a lot of good friends and a lot of good support enabled me and convinced me that I don't have a better choice but to be and do things for IIT Madras and in India.
That's amazing. Can we just today looking at this place, of course, we say is the best place to build. There are a lot of startups. There's a Center for Innovation, CFI. There's the research park. It feels like everything is set. You can just come and do something. But that journey that you're talking about from when you came back to now has had, many building blocks that have come into place. And I think I would like to hear from you. Maybe outsiders may not know so much, but there's this structure called the ICSR, which sort of forms a bridge between what IIT does and the outside world. Can you tell us what ICSR does and how its influence has grown? And
Sure.
so, of course, just to set the context for the audience, Professor was the dean for ICSR for
6 years.
a long time. Yeah, 6 years.
6 years. 2012 and 2018.
Right.
So, yeah, the ICSR is the IIT's window to industry. It's also ICSR's window for research that is funded by any other organizations like the Government of India entities or the quasi-Government of India entities. Now, IIT as a whole used to be initially, over the, from 1959 to probably the mid-90s, the mandate primarily was to teach undergraduate students and teach it well, and hopefully the students go out and make a difference. Now, as India as a country matured, we realized that if you look at the US or the Europe, most institutions like MIT are also known for their research. So I think there's a transformation of thought process to say that we're just not going to be only a teaching institution. We need to be a research institution also. So when you say research, you have two types of research. One type of research is where you don't need much money to do the research, where you can write equations and solve problems sitting in your room. But a lot of research, particularly in the field of engineering and largely also in science, requires a lot of money. You need equipment, you need manpower, you need supplies, you need chemicals, you need electronics, you need, to travel. That requires a lot of money. So the transformation of the mindset of a faculty or the institution as a whole to say, hey, money is required to do world-class research was what prompted the genesis of a small organization or center within IIT Madras called the ICSR. It started probably in the early 90s or maybe even earlier than that. I think we celebrated the 50 years just a year or so ago. So, but then it was still a small part of the campus. So I took over in 2012. By that time, the processes were in place and fairly mature. But there were a few things that I realized that we could do better. So some of the things that we probably took upon ourselves to change and do better were, first of all, we wanted to make sure that the intellectual property that was generated within the labs of IIT Madras needs to have an impact. And one of the ways by which you do impact is to make sure you protect the intellectual property and then channelize it in the way that you think is best, whether you actually monetize it, whether you make an impact or social ventures. But if you don't have the protection, then you can't do that because somebody else will take it and do whatever they want with it. This famous CSIR turmeric example being one of them,
I have no idea. What is this?
Okay, so there are US patent application on turmeric. for medical benefit, which is something that we behold for centuries. Okay.
So you're saying that ICSR was so if somebody in the industry or a government or a quasi-government organization wanted to work with a lab in IIT Madras, they would first come to ICSR.
Exactly.
And then you were talking about how one of ICSR's big innovations in the last decade has been to formalize like a IP policy.
Absolutely. Okay, so we had a IP policy before, but we had to completely look at it to make sure that IP policies work. For instance, one of the things that we did was today, which is very true, is we assured our faculty that it will not affect their publication, the pace of publication. We also wanted to say that we can get an IP done, or IP protected, I would rather say that, within 24 hours. Previously, it used to take 1 year. So we got that process down to as short as 24 hours in exceptional cases, but highly systemized. So just to let you know, if you look at the data, 2011 or 12, we probably filed about 20-ish IPs and mostly IP in India. I'm sure you have done some article not long ago, which says that today we probably file about 400 IPs a year.
Yeah, more than one a day.
And probably 25% of that is something that goes filed abroad, right? So that is the first part. So we need to create the IP portfolios, make it easy, make it accessible. Then there's a second part to it. How do you make the impact? So again, there were very early days where we were still trying to figure out how to do that. So I remember that I happened to meet somebody somewhere and who I knew from some other company, his affiliation. And he said, I just started an IP for one of the, KPMG. And he said, can we do something together? So KPMG came on board probably in 2012-13. By that time, we had hired somebody professional to actually manage IP within and started creating this, office or calling IP cell that looks at both evangelization and creation of IP for IIT Madras, but also how does that IP become something of impact. And today I would say that on the impact side also, we are probably leading the way nationally, where academic IPs are finding an impact in many fields, whether it's an industrial use or whether it's a social use or it's a societal use. I would say we certainly have made a big difference.
That's very interesting. I think the way you're saying it makes a lot of sense because often the criticism towards IITs at a national level is that everything is very academic and it's like it stays in an academic zone. But if this IP cell or this policy works in a particular way that it's sort of nudging it towards impact, that makes a lot of difference, right? And in fact, ICSR itself, a lot of the projects from ICSR are about applying what's happening in labs into the industry in and around IIT and in and around India, right?
Be honest with you, it's just not India. Even as way back, one of the things that we do is most problems, research problems, and are global problems. If I have a problem, say, in a refinery in Chennai, it's very likely the same problem exists in a refinery in Houston or somewhere else. So the many problems, research problems, are global problems that we can solve. So we need not restrict ourselves to local industries. So I would say that we have never looked at problems from a only local perspective. There are a few problems that are more local. So actually ICSR has many clients that are not necessarily local. We have Boeings, we have Airbuses, we have Exxon Mobiles. Many of them are global clients who work with faculty and students of IIT Madras. And we are looking at solving global problems that have impact. Similarly, if you look at it, we are looking at socially relevant problems, whether IIT Madras is focused on solving several problems that are local. First is clean water. It's something that we have focused on for a very long time. Electricity to all. When the Prime Minister announced that every village in India is for electricity, the last mile, a lot of it is done by IIT Madras faculty. Low cost construction. When Prime Minister says, I want a roof over every citizen of India's head, IIT Madras has this modular housing method called as GFRP, where we actually build homes within 20 days, 30 days. These were revolutionary ideas 10 years ago. Now, of course, you see many, many more of such ideas coming up. But we were pioneers in several of these absolutely critical research and development that we were doing.
Yeah. I saw this recent article about Supreme Court judgments being available in all languages. And then I realized that there's some IT and tech being used there.
Absolutely, absolutely. I mean, we are focused. In fact, there's been a very dedicated team from computer science department that has gone unbelievably, advanced in how, especially you must understand that our language is very different from English, okay, in many ways. And hence, I mean, these guys have done an amazing job. So when, not too far from today, it's my wish that I can sit in a classroom, the instructor can speak in any language, but I'll have a headphones and I will be able to listen to that instructor in the language of my choice. Yeah.
And it's not manual, it's automated.
It will be automated. Yeah. It will be AI driven. It will be driven by the language models, not the large language model, by the, language conversion models that our faculty have played a big role in doing it. So,
Oh, absolutely amazing. So we spoke about three infrastructure layers. One is the lab setups that we have, the centers for excellence. Then the ICSR, which is like a single window system, or may not be single window, but which is like an interface, like a window. And we also spoke about the IP policies. Can we talk about the incubation policy? Because I think a lot of that came around the same time, right? 2009, 10.
absolutely, absolutely. So, I must admit here that a couple of sister institutions like IIC Bangalore, IIT Bombay, and also IIT Delhi had a huge head start. They already had a policy and a process by which incubation was possible. But when I came to India in 2000, I found a situation that not dramatically different from when I went to US in 1984. When I went to US in 1984, if a faculty says I have a company that I'm incubating, they'll have to speak in very low voice because it was not an accepted norm.
Oh, okay. Is it?
Yeah.
Okay.
In 1984, if an idea, so I give you an example for my own case. My advisor had a company.
Okay.
Okay. And he would speak to me in a very hushed voice saying, I am not supposed to say this to anybody else. But then he used to make me do some work for the company and he used to pay me some little few dollars extra and a Pepsi and a pizza on the side. And I was very thrilled because I could make some extra pocket change by doing some coding for his company. All right. But it was a well-kept secret. In US, things dramatically changed from 1984 to say 1990, where universities started saying that unless a faculty wants to look at a startup or those days it was called a small business company in translating the research, your promotions or your tenure were affected by that. So it became from a well-kept secret to something where everybody started celebrating. I saw a very similar situation when I came here. So in fact, I must say that I in fact inquired about startups and everything in 2000 2001, and everybody says, "Oh, it's a bad word. You're supposed to teach." Now maybe you can do some research also, but if you say talk about anything to do with patenting or more you are going to be involved starting a company, it's not legal. So interestingly, that started changing. It's not like there was nothing happening, but everything was happening in a very, very clandestine way or less, open way. But that's attitude started changing. So I remember getting a call from then director Prasanand in probably 2010 time frame. I don't remember exactly what day it was, and saying that, hey, we started working on incubation policy, but we need more work on that because we need to get this through the board of governors of IIT Madras. And the board of governors has a very mixed, eminent people from very mixed backgrounds. There are people from central government, there are people from state government, there are industrialists and others, academicians. So how do you make it work? So I was fortunate to get a few of our colleagues of our faculty together. We spent about maybe almost a year working on several iterations of that. And towards, I think, the later part of 2010 or early part of 2011, we actually got the board to agree on it. Interestingly, I remember one of the government official in the board said, I have to place on record that I object, but please override my objection and go ahead. Okay, treat me as a minority objection and please move forward. I think this is the right thing to do. So incubation policy was, if I'm not mistaken, approved in 2011 ish. I don't remember exactly when it was approved. And that's when we could actually get things started.
This is very interesting. I just if I'm right, the IIT is formed by the IIT Act, which tells how the board of governors should be formed, and there are government visitors, and there are professors who should be on board by virtue of their position, and there should be some, I think, industrialists who should come in, right? So it's a varied audience, and any structural policy change has to be approved by the
Absolute
board. So when you are saying that it took 2-3 years, you're saying that everybody had to be convinced that this is the right thing and there are checks and balances in place. It's not that one day you decide and
exactly. So see, we try to keep the message the same, but then the language had to be acceptable to this, demographics which are very different from central government to state government to industrialists. All of them had to be convinced.
and you're also looking to build something that will last 40-50 years and enable the growth of
exactly. In fact, to be very honest with you, the government has put out its own incubation policy a few years later, and if you compare them, you see too many similarities.
very interesting.
So today, any institution, academic institution, can go to the government's website and download the policy and adopt it. The policy, if you look at it, is almost similar to what we had in the first place.
And in the 10 years since that incubation policy got set up, I think almost like 400 startups have come up.
I would say more than 400 have come up, but we had to set up something called an incubation cell. So incubation cell had to be an entity. So we were looking at what is the right entity to form. So there were so one of the things we were looking at was, can we make it into what's called under the Tamil Nadu Society Act and make it into a society, a not-for-profit society. But then we realized very early on that there was a problem with that because a society under the Tamil Nadu Act would not be able to hold any equity or shares in any of the company that it is incubating. Now, that was not the case with the National Act, which is why Bombay has a society called SIGN doing it. But we couldn't do that because we were subject to the Tamil Nadu Society Act, which had a clause that was sort of preventing us from doing the right thing. So after some deliberation, we finally found out that we can actually leverage the fact that we already have a non-for-profit entity called the Research Park, IIT Madras Research Park. And so we created this as a sub-Section 8 company that, it used to be called Section 25 in those days. Okay. A not-for-profit sub-entity of the IIT Madras Research Park, and that's the way it's been operating. And so it was probably 2013 before all this happened. We structured it. We found a CEO to operate it. And that was the starting part of the journey. But by that time, the incubation, sort of the energies had started to emerge. We had quite a few faculty and students who really wanted to start these companies. So, as a sort of a intermediary, ICSR took upon itself, said that we are going to allow you to start these companies, but with small rider pending the approval of the incubation cell. Once it starts, then you will be under its umbrella. But till then, ICSR was babysitting them. So we were, if I'm not mistaken, about 16 companies, some of the early companies, including Lemma Labs, or Hyperverge. I forget which one.
My old company also.
Yeah. Several of them were sort of babysat by ICSR. And then once it became, IC incubation cell became a viable entity, we will sort of transfer everything to the incubation cell. Right. A company like Yarn Data, one of my companies called Dhwani Research, all of them were initially started within the ICSR framework. And then it was handed over to the.
And just to stick on the topic of Dhwani, Dhwani has become quite big now, right? So you wanted to tell us what Dhwani does and what its impact is now?
Sure. Dhwani actually is now a group of 3 companies today. Dhwani looks at how non-destructive testing becomes automated. So this goes back to one of the missions that I had when I came back to India. When I came back to India and I looked at what is happening in India in my field of NDT, I found that 95% of the equipment and the solutions that are used by the industry all came from Europe, US, or Japan, or Korea. Almost nothing that was developed within India. So that's kind of, and that's why we started working with the industry and as IIT Madras, we started providing solutions to the industry. As time went on, we found that we have very limited resources to actually support industry. We can make one new development, but to make 100 of these mugs is not IIT Madras' job. So we definitely need another vehicle. So there are your 2 options. You can either transfer the technology to somebody who can do it, or do a startup. So Dhwani was basically started to make automated systems that will go into manufacturing companies. Let's say I'm manufacturing this mug in large numbers. I need these mugs to be inspected so there are no cracks in these mugs, so that when you buy and you take it home, this will remain intact for many years. So with some mug, or whether it's a shaft of an automotive component, or whether it's a small valve of aerospace, hydraulics, they all need to be inspected. So we were making the automated system, and the idea was to make it automated because you get better reliability, you also get better functionality. So that's kind of how we got started. Now, we found that as we were doing this, data analytics became a very big part of what we were doing. But then the people who work on softwares and data analytics are very different from the people who work on mechanical systems and electrical systems. So we sort of decided that it's a good idea to sort of separate them out into 2 different entities. So we have a company called Dhwani AI that started in 2019.
Okay.
From basically we took it was sort of a hived off from the original company, and that became a separate company. Today, they just don't focus only on data analytics from the manufacturing side. They also look at data from the operation side. So, for instance, if I have a refinery, and if I'm getting a lot of data of X-ray images, ultrasound images from these pipes, wells, how do you automate the entire data analytics and data management? So this is Dhwani AI's main forte. Today, they are having clients. Dhwani AI has clients that like L&T, Reliance, Aramco, Shell, Baker Hughes, very multinational companies where we are helping them manage the data of their X-rays, ultrasound, and many others, and create value to that. Dhwani Research continues to build systems. Today, they build systems that are as small as a tabletop to as big as something that is a rocket motor. So today, if you ask me the example, Chandrayaan, almost every other component of Chandrayaan was inspected by a system that was built by Dhwani.
Nice.
Okay. So today in ISRO, across their various locations, we probably have 10 to 12 inspection systems, and every year we are providing one or two more solutions to them on a daily basis. But it's just not about strategic sector, it's all about industry also. So whether it's Tata Steel, Jindal, whether it is Cummins, whether it's TVS, everybody is a client to Dhwani Research. For Dhwani Research, only like a month ago announced that they got the 100th system delivered. So they have delivered 100 automated systems to industries in India and also a few systems to the Singapore, Malaysia, and Saudi Arabia and Middle East. So slowly they're expanding also. So Dhwani has about 125 to 130 between the companies, 125 to 130 employees, and they have a manufacturing facility 4 kilometers now from IIT Madras. And we're very proud of what they're able to do. The impact that they have is that ISRO probably would have to import these large systems from somebody outside India. And whenever there's something breaks down, they will be stuck for 6 months, 8 months for somebody to come from abroad to repair it or replace it.
Interesting. Very interesting. We are on your first startup, and I think you're a co-founder in almost 8-10 startups.
Something like that, yeah.
Can we talk about a few of the other ones? Detect, Xyma, Planys.
Sure. So, see, Dhwani was a sort of a very scary proposition because that was the first one we started. At that time, while I have had some experience in the US, but doing something in India was a very risky proposition. And especially with the ecosystem that we are building here, everything was new. Nobody knew exactly what to do. So that was Dhwani actually started in 2010, and then nothing much happened. So around 2015, that time I was a dean. I was approached by a couple of the guys who had won this Amog product, which is part of the Bedlam C5 has become quite well known. So this couple of these kids had built this underwater robot. They went to San Diego and actually did quite well there. And then all the fun was over, and then suddenly they knew that they were graduated. And then what do you do after graduation? And a couple of these guys said, we don't want to go and take a job. Interestingly, same time parallel, there was another guy called Tanuj Junjunwala who was not a part of this thing. He was also doing something in robotics and underwater robotics. It was a mechanical engineer's final year project. So the Amog guys came and said, what can we do? And I said, well, why don't you think about it? Now that the incubation things are all in place, why don't we start out? So they started working on it. As they started working on it, a few months later, I got a call. Tanuj had by that time joined Tata Motors. And then I got a call one day from Tanuj and say, you talked to me about something 6 months ago. And I said, no, I want to go get a job. But I really want to come back. Is there an opportunity for me to come back? I said, you don't want to know what salary you're going to make when you come back. You'll be probably a small fraction of what you're making at Tata Motors. He says, no, I'm not worried about salaries. I really want to do something different. So Tanuj actually came back, joined the other two guys, Vineet and Rakesh, and we said, let's get started. And then they said, I said, initially the business model was very different. They wanted to just make these robots and sell it globally. But then there were quite a few others who were doing that already. And the risk was that if you do it well, then China is going to come and cut you and you are going to. So is that model the right model? So knowing my field and what I do, I said, there's probably another way to go about it. That could be inspection. then amount of infrastructure underwater is huge global. Can we make sure that and today divers go in. It's a huge risk with divers. First of all, availability of divers is a big problem.
Wait, divers going. So these are offshore oil rigs,
Yes,
harbors.
anywhere, even in big tanks, people jump in and then they do the inspection. Okay. And they're very expensive, not easily available, and the risks are high.
Safety risk is very high.
Very high. And then the data that you get is not very great. At best, you will have a guy taking underwater camera photographs. That's it. Can we change that paradigm? I think these guys, fortunately, agreed that it's not a bad area to look at. Again, we were very fortunate. We were very fortunate that many industries supported us, many good people supported us. So we started looking at making these. And once you go into from a competition, when you go try to make a robot that works in the field, it's a massive upgrade in terms of reliability and robustness. Because unlike a competition where things go wrong, well, okay, you get a consolation prize. Here, if something goes wrong, you get penalized. Right? So it has to work every time the same way. So that robustness was something that took a while for us to build. Again, we were fortunate. We got, at that time, Kiritsu Forum was fairly active in Chennai, and they've become active. So we got seed funding from Kiritsu Forum, started building the teams, started getting orders from various clients in India first, the ports, the dams. Later on, Reliance started coming in and saying, we have these big storage tanks. Can you look in this water tanks? So started building, and today, Planys is about close to 200 employees. We have global presence. We just finished a major project in Singapore. We have just received a very large contract in the Middle East. So we are now it's a global company, and are professionally managed, invested in, and we just went to a Series A investment. So I think it's a cruise control from my perspective.
It's very interesting. Like, if from your point of view, there is a research energy and there's sort of like an entrepreneurial energy, right? Like, so, and I just want to extend it a little bit. From what you have said, professors were initially expected to be great teachers and then great researchers, like the next decade.
Right.
And now almost there's an expectation of, being able to patent and maybe spin off a startup from your lab. How do you manage this? Like, isn't it like like a professor ends up having like 3 or 4 KPIs? How does this work?
Um, I would say that's true for just not for a professor. You go and get a job. What happens? You work on a problem. Then you get a little promotion. You work. Then you have 3 people working under you, and they are working on 3 different problems. Then as you go up the ladder, you start to manage a large different types of projects, so very similar. So as I said, my first, came back in 2000, started the center in 2001. First venture was in 2010. Then the next venture was 2015. But then by 2015, the ecosystem of IIT had changed. Things were more systemic. We had a system to actually take an idea from the lab and move it to market. It was easy to do things. Ease of doing business was much easier. So by the 2015 onwards, we almost have almost a company incubated every year from my lab. So 2016 was Detect Technologies, which is a very large company today. 2017 was a spin, sort of a hived off from Detect, was a company called as Maximal Labs, right? And then every year we have had a company that's come out. And
Once again, so Dhwani does entity instrumentation plus AI.
right.
Planys does underwater inspection. What does Detect do?
So Detect actually, again, there is always some pivoting that happens when you work with industry. So initially we were looking at, we had a very unique patented sensor for high temperature corrosion monitoring of high temperature pipes.
Okay.
We call that as gums. So this was a co-invention by Tarun Mishra, who was my MTech student, here a degree student, and myself. And later on, we had the fortune of having Reliance actually say, I'm going to actually support this work, and whatever we help you productize it, and we want you to try it out on our, and we will also buy 200 of these sensors if it works. That's a great deal for us. So we started Detect. And then we onboarded Daniel and Hari, and later on Karthik, the 3 other founders a bit later. So this was a 2016 company. Okay. And we had, on day 1, we already had a project with Reliance to actually prove this technology on their plant. Nice. That's how we started. Very soon, we started seeing more and more problems when we were in Reliance. So one of the things they said was, hey, we can't reach many of these the big pipes which are very high. So we came up with a product called Noctua, which actually was a drone, but was doing actually NDT with drone. Okay. Which humans used to do by climbing or by scaffolding. But again, safety was an issue, productivity was an issue.
And time also.
Time, that's a productivity was an issue. So if you think of a big storage tank, with all this, it should take somebody 1 week to look at it. We could do it in 1 day within a room and absolutely safe. So this is how we started. Very soon, we realized that the volume of data that we are generating and everybody else is generating and the information is coming actually can give you a predictive capabilities, prognosis capabilities. So Detect came up with a product called T-Pulse, which is now pretty much used in a lot of process industries across field, whether it's a cement factory, steel industry, a lot of refineries. They use them so that they not only look at asset integrity management, they also look at it from a safety, human safety management also. So whether it is a pipe that has a potential to fail, say 1 year, 2 year down the road, or it's a human operator who has left something somewhere which he or she should not have done that, we pick it up using cameras, drone-based cameras, sensors, anything that the company has. How do you bring it all to one platform and build intelligence and automate the intelligence building? So many of our IIT graduates, some of our best students from computer science, mechanical, found exciting that they can actually use these tools to do hard industrial problem solution. Okay, so AI becomes a big part of the entire thing, right? So today, I would say that Detect is more of a SaaS company, which is providing asset safety, asset integrity, human safety, compliance for large industries, Shell, Exxon, Adani's.
Nice. When we look at companies like Google, which we know have come out of university setups, that model is still new, right? But that's what you're saying. You're saying that there was a project that came from the industry, or there was some research project that was going on, sort of found an application, it led to some IP protection, then a company, and then that company has a life of its own. Amazing. I also feel like it's interesting that the topics that you're talking about are hardcore industrial engineering topics. Sometimes when people look at entrepreneurship in India, they think of Zomato, Flipkart, which are great companies, and probably also solving some interesting engineering problems, but not in the hardware space. I've also heard this term being used now called hard tech, which I love because it's hard. Of course, it's hard, but it's also hardware. It's short for hardware tech. Would you like to talk about Xyma also? I think Professor Prabhu also already spoke about it once.
Okay, so interesting, Xyma basically leverages research that I've been working on from 1995 onwards, believe it or not. Yeah. So the work started way back in 1995 when the Department of Energy was looking for a technique by which they can measure the viscosity of glass material. Okay. But glass is melted at 1000+ degrees temperature. How do you measure temperature? Thermocouples are not very good, and they want to make sure that none of them if you put a thermocouple inside, thermocouple is a very sophisticated form of thermometer. Okay, They don't want you to contaminate the class. So there were issues. So we developed this technology. One of my first PhD students in US actually worked on it. How do you make sure that you can do that? I subsequently worked for several companies. Okay. And then I had a PhD student, Suresh, who actually developed, morphed it into something where we can expand it to where we can measure, say from here, if I want to measure at 50 meters away temperature, I could just take a wire from here and then lay it, and I can measure the temperature there. So that's kind of how and I can also measure the viscosity of what is surrounding it. So that's kind of how so this is a high temperature sensing technology. Interesting. We developed something close to 10 to 12 patent filings, which were also refiled in other countries, probably about 25 to 30 papers. And Nishant joined this team when Suresh was towards the later part of his, PhD work. And Nishant Raja continued the work, and we solved a lot of, we were working on problems that are from semiconductor industry to steel industry to polymer industry and a few other case studies. And we had the support of all these companies. We had the support of Tata Steel, the support of Lam Research, which is a big semiconductor industry. So they were funding us to evaluate these technologies for their problems. So somewhere along the way, we said, wait a minute, there's some value in this. The industry is liking it. And some of them we went back and asked, hey, will you buy? If I make the product with these specifications, how many will you buy? And the answer was very encouraging. So that's when in 2000, I think 19 or 20, I forget, we decided to launch this company called Xyma. And Xyma basically stands for wave in Greek or Latin, I forget. Okay. So we are using ultrasonic waves that are confined in materials like a wire. Okay. And nothing new, because you and I used to chat in a matchbox,
Telephone. Yeah.
telephony, exactly same thing. So I am saying from one, the only difference is that the other side is just sending back. So imagine the other part of the telephony becomes my sensor.
Right.
So exactly the same thing I'm using. All right. So the wave actually goes, measures some things or gets modified, and the signal comes back, and I sort of decode it, and I say this is what is happening that point. Okay. So this technology has become quite popular. Nishant and then later on Ashwin, who was a mechanical engineering student from IIT Madras, joined the team, and together we are now present in, we have technology that's being used in US, in Europe. Some of the big names, SKF is one of the largest bearing manufacturer in the world, is using our technology. Vedanta, Emirates Global, these are big companies now using our technology, and I think sky is the limit, because we have technology that doesn't have too much of a competition per se, and so we are in a very sort of a forefront. We have some pole position in some of these technologies.
Nice.
And we're making a huge difference to the value proposition these companies are able to do during manufacturing.
Very interesting. So now I want to ask you a more meta question. We've been hearing from others also that, IIT Madras is now a great place to build, like the best place to build, right? So, what makes it so? And from your point, because you've seen 4 directors, right? Professor Natarajan, then
Yes.
Professor Anand, Professor Bhaskar, and now Professor Kamkoti. So, what has changed over time, and why is it? What are the blocks that makes it so?
As I said, it's an ecosystem building. No ecosystem that works well is built on one building block. You need many, many building blocks that makes the ecosystem work. So as I said, ICSR, which we transformed in the 2012 or to 80, which I helped transform, and I'm at further transform later, is one building block where intellectual property filing became doable. Another is the fact that we created a lot of industry interactions. See, a lot of the solutions, as the hard problem solutions, come from the industry. and industry is your market. Sometimes such hard problems also come from social requirements. So when you do research in your lab, you need money, as I mentioned before, and that money comes from ICSR. So ICSR is a very deep building block. Another huge transformation was this exact C5. Actually, when C5 started, it was supposed to be a small tinker lab for students to have a little fun. Very soon we realized that companies like Aether, Hyperverge started to emerge from these ecosystems. And today, the kinds of things that the C5 is coming up with is amazing. Just it's a place where student gets inspired. As to any student at IIT Madras walks in, gets inspired. As you rightly put it, the mantra is walk in with an idea, walk out with a product. Whether you walk out with a product or not, you walk in with an idea, you change the mindset of the person. Person becomes a maker. And that's a fundamental change that we have created with students. So whether the guy does it here or the person does it outside after they graduate, doesn't make. IIT Madras is proud that we have created a maker. Now, added to that, we started looking at how do we help students. So we created these scholarships that will allow the students to stay for one more year, and they can work on their ideas with a sort of a stipend. They get to stay in the hostels, and that allows few of them to actually persist with their ideas. Soon that became a program for Nirmaan, which is now one floor above this floor we are sitting. In 2017, one of our famous alum called Deshpande came and said to us, hey, we are doing something called ICOR in the US. And this was a brainchild of Subra Suresh with Deshpande. Both are very famous alum from IIT Madras. And they said, look at the money that is spent on research in the US. How much of it really gets translated into impactful solutions? Can we help the process? We know very well that journal papers are published. PhD students and master's students are coming out. Great. So we're helping certain demographics. Are we helping the society? Are we helping the industry? Where is the impact of the work that you're doing? Can you leverage that? And that led to this program called ICOR that NSF started funding. And today ICOR is one of the most successful programs that the National Science Foundation of US, is very happy with. So he says, I will give you some money, but please find a partner in India who will also match my money. And that's when it took us not even a few days. I remember a 15-minute breakfast with Chris Gopalakrishnan, and he said, I am in. So that's why we formed this Gopalakrishnan Deshpande Center.
So Gopalakrishnan in that is Chris Gopalakrishnan.
Yes, Chris Gopalakrishnan from Infosys. And Deshpande and Jayashri are huge alum, donors of IIT Madras. So together, we formed this Deshpande, Gopalakrishnan Deshpande Center of Innovation and Entrepreneurship at IIT Madras. We had the fortune of having a person called Raghuttama Rao, who happens to be an alum of IIT Madras, 84 alum, and then he's been there, done it. So he joined as a CEO. And I remember the first day he joined and he said, what do I do? And I said, I do not know what to do. I have no idea what to do. And so we were sitting in the room and said, okay, what is this ICOR program? So we did some digging, and we in fact took the help from a university called George Washington University, who was doing the ICOR program in the US. We brought them here. We said, teach us. So they said, the best way to teach is for you to do it. So what does ICOR do? Basically, ICOR looks at the fact that the mindset of a faculty or a researcher in a university system is looking at how do I publish papers? How do I graduate and get a good job? Right? Or how do I get the next project funded? Nobody is looking at it and saying, can I actually make this the product or solution or a company? It's not natural for them. So can we make that a bit more natural? So what we do is we ask for ideas. So we do not actually support any ideas in terms of research. We say if you have an idea, maybe you even have filed a patent or something on it. Do you want to find out whether it has a value beyond publication? So then we also ask you to team up with a couple of students. You come and sit with us for about 6 to 8 weeks. So we do in a cohort form. So you typically a cohort has about 10 teams. Each team will have 3 to 5 people. One of them has to be a researcher, like a faculty. So we look at it and say, what is it that you have? Who can use it? So immediately everybody has an idea. I have this mug. This is the best mug that anybody has designed and built. And Amrutash must buy it for $50 rupees. This is my thing because this is the best mug. His mug is chipped, but this mug will never chip.
This mug is not chipped.
Okay, I'm just go joking. But so now Amrutash looks at it and says, "Oh, nice product, but I'll pass on it. I'm not going to buy it. Why? Any number of reasons. I didn't like the color. It doesn't. I don't need a mug. I have a mug. I'm okay with a chip mug, or maybe it costs too much. But I'm the creator. I'm passionate about my creation.
Yeah.
I will tell Amritash, no, Amritash, this is the only mug you should buy. Right. Okay. And I said, how do you change that mindset? To say that, how do I make him think, or the faculty think, that Amritash is a client, he is a customer, and you need to tune this to Amritash's requirement. Yeah. Amritash, change the color, I may buy it. Reduce the cost by 10 rupees, I may buy it. Yeah. Right. So how do you change that mindset? And that's what we go about doing. So in the 6 to 8 weeks, the mindset of the faculty and the researcher dramatically changes. They may come out with a product. So today we have, and this is just not IIT Madras, we do it Fan India. Very recently we are happy to say that DST has joined hands with us. Okay. And the first cohort with GST just started last week. Okay. So now we hope that we can expand this even more, nationwide, pan India. But as it is, we are pan India. We have over 65 institutions, STEM institutions in India, partnering with us already. Now with DST, we hope to get it to 200 or 300 in the next couple of years. And just want to say that about close to now about 1,700 or 1,800 entrepreneurs have gone through this program. Close to 400 to 450 faculty have gone through this program. Today, we have probably about 140 companies that have been incubated by the people who have gone through this program.
Wow. Okay.
Some of them are examples. Our own faculty, Satya Chakravarti. He was probably our best student ever. He came at 3 times. He said, first cohort, he said he learned a lot, but he didn't learn enough. And he came back again. Satya Sheshadri. Some of the guys you incubated, Prabhu Rajagopal. All of them actually went through this program. So we are just not curating ideas. We are curating entrepreneurs. We are curating faculty who become entrepreneurs. So that's another part of the system. Then you talk in terms of going from there to the incubation cell, the research park, which is one of a kind in India today. The process of going from a lab all the way to market becomes fairly systemic. And the systemization is what's changed in IIT Madras. That's why 400 plus. Today we have incubation cell, we have a Pravartak is an alternate for a mechanism for doing that. So you have enough mechanisms where you don't have to think and say, how do I do it? It's only a matter of, will you do it? And if so, this is the way to do it. That's a big change.
It's amazing. Really feel jealous of the students who join.
Me too. Me too. If you think that you have to be jealous, I have to be 10 times more jealous.
One last question, not a serious question at all, but I'm wondering if you are still teaching and you still take class. Which are the courses you're taking?
Yeah, I actually, believe it or not, I still teach. Uh, the last couple of years, I've taught mainly advanced non-destructive testing and evaluation, because a couple of the courses I used to teach before, there was a curriculum revision, and those courses were not continued. But I do teach. I teach advanced non-destructive testing, which is senior level for undergrads, and all graduate students are welcome. So I teach that still. Teaching is, of course, our profession, so we continue to do that.
Yeah.
And
I, on a personal note, I've heard that you play tennis.
yes, I do.
Do you still play tennis?
I do, but the last couple of months has been pretty brutal on my because of travel. But yes, I hope to resume tonight.
Okay.
Today evening, back after a month or two of break.
Okay.
Yes, I do.
Because IIT Madras has some really good tennis courts.
They are not too bad at all. And see, for us, our knees, joints cannot take the hard courts.
Right.
So we have a nice clay court, pretty much run by the faculty alone. So we sort of have a small faculty tennis club.
Okay.
And so we hit the ball, and it's a huge stress reliever, right?
Yeah.
So the days when I hit the ball out of the court, they know they're having a bad day at work.
One interesting thought I had was, when you talk of building products, it's a hardware product, it's a sensor system, it's an inspection system, it's a submersible, whatever. But in popular imagination, if I go to some cafe in Bangalore and people are talking of product building, they usually are talking now about software products, right? Does this amuse you, like when you think of products, it's hardware, but when the public thinks of products, they're thinking of software products?
See, in fact, when people say deep tech, I realize they're talking of software all the time nowadays. So that's where I started. Well, I like the think hard problem solution. That's a good word. Or I call it deep research products.
Wow.
Okay. So now I would not say that. See, software is integral part of what we do also. A lot of what we do has a huge element of software built into it. I would say that at the end of the day, we are trying to change the way we do things. So, so I have great respect for the Uber app or the Swiggy app, because they've changed the way I live. So, software has profoundly changed how we do things today, compared to even as recent as like 5 years ago.
Yeah.
All right. So there's nothing wrong in talking about getting great software products. The difference between a venture that you want to support will depend a little bit on what you are trying to do or what is being done. When I say example, let me say I take a Xyma example. It's hard, like what Kennedy said, no? We choose problems because they're hard, not because they're easy. Exactly true. But when I solve a problem for an industry that's operating at 1200 degrees Celsius, it's going to take anybody else a long time to get there. It may have taken me a long time to get there, but then I have a huge moat. Right. So there is a difference in the timelines. There's a difference in the mindset of either the investor or supporter or the client or the founders when you do look at deep research. But then deep research is going to play a very long term. You'll see that many of the software ventures have a much shorter life cycle. Now, Facebook was not the first in social media. In fact, you'll know many of them.
Yeah. MySpace.
Yeah, huge number of them. Yeah, huge Orkut. So many of them fail. Okay, that's true for everything. Okay, so yes, some of them make it big, but then the odds are making it big, and then the odds are making it sustainably big for a long time. Becomes much higher when you go to deep research ventures. Okay, so SpaceX is going to outlast X. This is my line of thinking. Okay. So X may reach
will have to reinvent itself.
you're already seeing that. You're already seeing it, right? It'll reinvent itself, or somebody else will come up with a better solution. Yeah. But X, unlike X, SpaceX is not going to go away that easily. Okay. If anything, SpaceX will keep growing. Tesla is going to keep growing. Right. Well, so that's my belief that when you have deep tech, Tesla has got some amazing deep tech in their products. Amazing deep tech. Yeah. The way they handle they completely re-engineered the way the battery packs were being used in the automotive sector. Right. So I would say that transformational concepts emerge from deep research, while soft research or soft products actually transform the way you do things.
It's an interesting thesis.
Nice.
Professor, I learned so much from you. I have not been in your class for the past 20 years, but that's felt like a class. I also want to, my gratitude for, I mean, when you were answering at some places, you answered like as if I was an engineering student. So my gratitude for giving me that that much that I could follow you. Yeah, and thank you for joining.
Thank you so much. See, for us, gives us way more pleasure when one of our students does very well, and I read about that in a newspaper or TV, or comes back and says what you just said. It makes it all worthwhile. Okay, thank you.
And before you go, please like, share, subscribe. Thank you.